All right, I'm just going to do a quick video on molarity and stoichiometry. This is a practice question. So it gives you a chemical equation, and it says if you have 24.8 milliliters of 1.9 molar NaOH, so it tells you the volume and the molarity of this, and it's needed to neutralize 40 milliliters of this. It wants to know what the concentration of this was. So what we have to do is we need to remember something very important that we learned about earlier this year, and I'm just going to write it over to the side here, and that's that molarity is a way that we measure concentration, and it's equal to moles over liters. Okay, so capital M for molarity is moles over liters, and we can manipulate this equation, and if you want, you can make a triangle out of it, where we put the moles in this part, the molarity here, and the liters there. Now notice it's in liters, so if you have something in milliliters and you want to plug it in here, you have to change it to liters first. So if we're looking at this first part here, I have volume or milliliters, I could change that to liters, and I have molarity, so I could find the moles of NaOH doing this. So that's what we're going to start out by doing. So if I'm looking for moles, and I cover it with my finger, then I know I need to do molarity times liters, okay? So let's go ahead and say moles is equal to molarity times liters. Okay, so I'm going to plug in my molarity, which is 1.90, and then I'm going to plug in my liters. This is in milliliters. So to change it to liters, you have to move the decimal place 3 places to the left. 1, 2, 3. So it's going to end up being 0.0248 liters. Okay. Okay, so you do your molarity times your liters, and that will give you how many moles of that substance that you have. And that gives me that. Okay, and I'm just going to wait to round until the end. 4, 7, 1, 2. Okay, and that's our moles of NaOH, okay, because this was the volume and the molarity of NaOH, so now we have the moles of NaOH. Okay, but we need to go from NaOH to, we need to figure out how many moles of the H2SO4 we have, because in order to find the concentration of H2SO4, and again, concentration is measured by molarity. So molarity, concentration, same thing, okay? So we need to figure out how many moles of H2SO4 we have. So let's do a mole ratio. Take this number we just found, our moles of NaOH, and we can do a mole ratio to figure out, so because I have moles NaOH here, it needs to go down here, so it'll cancel out. And I'm going to put my moles of what I'm looking for on top, which is H2SO4. Okay, now remember, this is where you have moles over moles, which means it's a mole ratio, which means we look at our balanced chemical equation to find those coefficients. So if I look at H2SO4, it has nothing in front of it, so that's a 1. And NaOH has a 2 in front of it. Okay, so now when I go ahead and do that, divided by 2, I get this, 0.02356 moles of H2SO4, right? Okay, so now I've got my moles of H2SO4. I also have my volume of H2SO4, which I could change to liters. If I have moles and I have liters, I can figure out the molarity, which is the concentration. So let's go ahead and do that, because I know that molarity is moles over liters, right? So I'm going to take my moles and put it over my liters, but I don't have liters, I have milliliters, so I got to move that 3 to the left. 1, 2, 3, which is the same thing as dividing it by 1,000. And that would be 0.040 liters. Okay, so I'm going to take that number, divide by my 0.04, and I get 0.589, and that would be my molarity. And capital M for molarity, and then this is for H2SO4. So it says, what's the concentration of H2SO4? Its concentration is 0.589, capital N for molarity, okay? All right, so that's my first example problem for you guys. Now, let's do one more. Uno más. This one says, consider the balance equation low. It says you got excess lithium sulfide. So again, if you ever have a problem, like a stoichiometry problem that says that you have excess of something, that means you can ignore it. Because that's just telling you, hey, this is your excess reactant, so you don't need to worry about it. Just worry about the what I tell you about the other reactant, okay? So you don't need to find limiting reactants or anything. Okay, so it says you have excess this stuff. And again, it gives you a volume and a molarity of one of your other reactants. It wants to know how many grams of this can be produced. Okay, so this is, we're going to take, just like we did in the last one, we're going to take our milliliters and our molarity. We're going to turn that in to find moles of our iron 3 nitrate. Iron 3 nitrate is this right here. Okay, so we know that moles is equal to molarity times liters. So let's take that information and do our molarity times our liters. This is not liters, this is milliliters. So let's move it 3 to the left. Boop, boop, boop. So it'll be 0.165 liters, right? So let's do our molarity times our liters. And that will give us how many moles we have of iron 3 nitrate, which is this thing right here, FeNO3. Okay, now we have moles of this. Now it's in moles, we can do a mole ratio to figure out how many moles of this we're going to produce, right? So let's go ahead and take this number that we just wrote down, and we're going to do a mole ratio to figure out how many moles of our iron 3 sulfide we can make from it. Okay, so we're going to go to moles of what I'm looking for, which is Fe2S3. Okay, and then it actually wants to know grams. So we could take this one step further, because then we know we can go from moles to grams. Fe2S3. Okay, sorry about the handwriting. It's not the prettiest. Okay, so here I see a mole ratio, because it's where I have moles over moles. This is where I change substances. This is where I look at my balanced chemical equation to find my coefficients. So it looks like in front of my Fe2S3, I have a 1. In front of this guy, I've got a 2. Let's show that those cancel. And then everywhere else I see the word mole, I'm going to put a 1. And then G for grams tells me to go to the periodic table. And I've already calculated the molar mass of this in the interest of time. So go to your periodic table, calculate it. I got 207.88. Okay? So now I can put that in my calculator. I can do the 0.132 divided by 2, enter, times 207.88. And I get that number. So 13.72008 grams. So let's go ahead and round that to 3 sig figs. 13.7 grams Fe2S3. Okay, that's how many grams. So what we did is we found moles. We did the mole ratio to find moles of what we're looking for. Then we converted to grams. Okay, and that is how you do a problem like that. So go ahead and work on the practice problems I gave you. Work them out on your own sheet of paper, because I'll give you the answer key to check back with your answers next week. So if you have your work all nice and worked out and organized so that you can look back on it, it will make it easier to figure out if you got anything right or wrong. Okay? All right. Good luck.